Good morning, good afternoon, and good evening, everybody. My name is Frank Yu. I'm with Kemp Technologies, and I'm the Principal Application Experience Architect. And today we're going to be talking about using load balancing to bridge hybrid IT components. So this is going to be an interesting talk. We're going to be looking at cloud, multi-cloud, this hybrid cloud, and that's what I mean when I say hybrid IT. And why we're there and what does it take to make it work for us as an IT professionals. So I think you're going to find some interesting concepts, some good bits of information, and hopefully some good takeaways that you can incorporate into your own practices. So let's go ahead and bring up the slides. And again, today's talk using load balancing to bridge hybrid IT components. And let's just go right into this. So first, I want to show you, this is a picture from the history books from the archives. And this is AT&T's Global Network Operations Center back in 2009. And I want to show you this picture because this picture shows us a very large operations center with lots of different screens, lots of different desks required, a lot of people, a lot of tools to be able to manage the network. And it's not because the network is really big, but it's really complicated. So keep that in mind as we go through and discuss this about the simplicity versus complexity as we get into these hybrid IT environments. So why cloud? What is cloud? Why are we doing it? And what's the benefits for why we want to do all these cloud things in terms of technology? And first, I want to mention that public cloud came about in 2006. Amazon created their cloud infrastructure, AWS, Amazon Web Services, and it was a big hit. And people started using them to put their applications and data into this AWS cloud, this public cloud. And AWS is really providing kind of that concept of the service of infrastructure as a service, IaaS, or platform as a service, PaaS, so that we did not have to manage that infrastructure. And then it became so popular. Then in 2010, number two, Microsoft created Microsoft Azure for their public cloud, and now we have lots of different public clouds technologies today. So we have Google Cloud, we have Oracle Cloud, we have IBM Cloud, all these various public clouds. Why do we want to go to this cloud? First, initially, when we did this, we were thinking, you know what? We're going to save so much money because we do not have to purchase all this equipment. We do not need to manage all this infrastructure because it's being hosted in the cloud. It's going to be great not having to have those people, equipment and deprecation, and have to refresh, et cetera, et cetera. But you know what? That's not true. We are not saving money in the cloud. I think most people that I talk to, and I think if you look at your books, you'll find that, going to the cloud, your IT budgets have not decreased because you went to the cloud. Most likely they've actually increased. But it's more of a CapEx, capital expenditure versus OpEx, operational expenditure. So there are some pros and cons to being CapEx versus OpEx, but cloud is more of an OpEx budget because you're paying over time for the cloud services to use it. Flexibility. This is a big piece. I mentioned this procurement cycle. So if I am in my traditional IT infrastructure and I want to build out a new application or a new system or expand, I have to go the process of making sure I have space, I have power. I have to buy the servers, the racks, all the equipment. I have to buy the applications. I have to do all these things, and that takes time. It takes literally, in many cases, months just to purchase all the stuff and get it in house before I can actually build and do my quote unquote IT related things. The flexibility of cloud means that I can do it whenever because they have this huge infrastructure already there and I can just do things whenever. It's awesome. It gives me the ability to do things on demand. Overflow. so related to this flexibility, if I have surges or possible surges in terms of traffic or application needs, let's say I'm e-commerce, and then we have holiday seasons, and we have something like Black Friday or Cyber Monday, which are these huge shopping surges. I want to have the resources to surge on demand. And when the surge is over, I can then get rid of those resources because I don't need them anymore. So I'm paying on demand, but getting on demand quickly and easily this overflow. And of course, there is the list ownership and management. So this infrastructure platform as a service that I mentioned, where I don't have to manage and own these components. Don't have to deal with the power. I don't have to deal with the internet connectivity of these public clouds. It makes it a little easier in my life that there are some things I can just get rid of in terms of responsibilities and expect or depend upon these public cloud services, depend on them. Excuse me. So now let's talk about this concept of hybrid cloud, because we have public cloud, this AWS, Microsoft Azure, Google Cloud, Oracle Cloud, etc. And now we're going to add this traditional, what I call traditional, or might call legacy, but really it's a private data center, my existing physical space that I use for my IT infrastructure. It could be a private data center. It could be, co-load with someone where I am using their space to build my own infrastructure. It could be, if you're a small company, it could be sitting in a closet somewhere in the back of your office. There are lots of different options, but you have this private stuff that you own and manage in addition to possibly the public cloud infrastructure that you are using. And then let's add this concept of private cloud. What is private cloud? Quite simply, is taking the kind of concept of public cloud and throwing it on top of my private data center infrastructure. So what I'm doing is I'm adding another layer within my private data center infrastructure, which we're going to call, and it's a little more than this, but we're going to call it virtualization. So we're going to virtualize our infrastructure so that we have the flexibility to put different applications in different locations using technologies like VMware, using orchestration tools like OpenStack, and there's lots of different other technologies out there, not specifically these ones that you have to use, that you can do to create this public private cloud, or software defined data center is another term that we use, SDDC. And we're going to take all these different technology concepts, architectures, public cloud, private data center, private cloud. We're going to mix it all together and create what we're going to call this Uber hybrid cloud. It's also referred to as multi-cloud. And now that we have people coming into this infrastructure, and we have people at the top, you can see here, coming through the intranet to this hybrid cloud. And now we have our applications, which is what we really care about. Because without the applications, why do we need the internet? And we have the internet because we want to run these applications so that we can get the applications and data to and from the people and the servers and databases. And the applications are spread across all these different environments: private data center, public cloud, private cloud. And in some cases, we might have applications in multiple instances. We might have them only in certain instances. It's a mishmash. It's varied. But we have applications sitting in the multiple locations now that these people need to access. And the one thing I want you quickly to take away when we look at this diagram on the right-hand side here is there's a lot of complexity being added. Remember that initial AT&T NUC picture that I showed you? We're introducing a lot of complexity. So it's not just a person accessing the application through one system, whether it's private data center or something. Now we have this thing where we are directing traffic to different cloud or structures, architectures, and the applications sit behind these architectures, and these applications are sitting behind these architectures and behave in different manners because the architectures are slightly different. Now you can imagine how the operations team is starting to feel trying to manage and support this infrastructure. It is getting complicated and it is complicated. But there are some benefits to all this. Why are we doing this? So, if it's complicated, we're creating all these things, there's got to be some benefits. Absolutely. Key benefits that we want to look at, the top benefits, at least from my perspective as an IT person. Number one, I'm getting rid of vendor lock in. I want best of breed and I want the ability to use things across multiple pieces and make it portable. That flexibility that we want in this cloud infrastructure, we want that in this multi cloud infrastructure as well. In other words, I don't want to be tied to AWS because AWS does something a specific way or has a specific function that has to be there for my application. I want to be able to say, move that application from AWS to my VMware software defined data center if I need to, or to my Microsoft Azure public cloud, etc. You don't want to be tied to any specific vendor. Number two, we get some interesting functionality by enabling extended cloud scenarios. So you might have heard terms like cloud bursting. So I have an application hosted in one location, and when that demand exceeds the resource capability of that location, I can do what we call bursting, and then push and create more instances or availability of that application somewhere else. So I might have an application that resides in my private data center. And only if the demand exceeds my private data center's capability do I start putting that application in my public cloud, such as AWS. This might be a good example for that e-commerce store that I talked about, where we now have the hot item for the holidays and everybody's starting to come to a website. We need more resources. We don't want to have to go through that procurement cycle that can take months to put the infrastructure in our private data center. We start popping instances of the application and database access to the public cloud is available. We pay for it on demand. And now we can support the customers coming to our site. Remove potential single points of failure. This is a huge one that I want you to think about because a lot of times we think we're going to the cloud because it's always there. It's this ubiquitous thing. I put something in the cloud, it's always going to be there. I'm always going to have access to it. Not true. Just because you put it in a cloud, whether it's public or private, does not mean that this cloud, and I'll put air quotes around that, you can't see me doing that, this cloud is always going to be there. It's not. You will see in the news all the time about AWS, Azure, other public cloud organizations having failures which cause sites and data to go down and be lost. It happens. This cloud is not this ubiquitous thing that just happens and appears and works. It's dependent upon infrastructure, just like the infrastructure that we have, except they are the ones managing it. A good example was earlier this year. There was a fire at a data center for one large cloud provider in Europe. And the fire took out one of their data centers of about, I think, maybe a half dozen to a dozen data centers that they have located throughout Europe and actually globally. For that area in Europe, which was in France, about 4.5 million websites went dark because this cloud provider had a data center fire. So physical problems can cause cloud problems. Human error, someone typing in the wrong configuration, can cause outages in cloud. So the single points of failure exist even in public cloud and cloud technologies. You need to design your architecture around those single points of failure, just like you did in the traditional legacy private infrastructure, private data center model. So, what are these concerns that we want to be addressing when we talk about this hybrid cloud model. Number one, multiple technologies to support. Each cloud technology uses a different technology. So, VMware has their own management system and their own configuration and their own language to configure their stuff. And you need to become, quote unquote, a VMware expert to be able to support VMware technology. Nothing wrong with that. But now I have that for my software defined data center, my SDDC, but now I also have my public cloud. I'm using, let's say, for example, AWS. And AWS has its own technologies and nuances and things that you have to learn, and you have to become an AWS cloud expert to manage the AWS cloud components. And same thing for Microsoft Azure, OpenStack, and all these other components. So when you talk about hybrid and multi-cloud, you're talking about hybrid and multi-technologies that you have to support, learn, and support and manage, mostly independently. This is going to be a huge challenge. We have different management tools. These management tools means that we have different consoles, different systems, different things that we have to use operationally and configuration, change control to be able to deal with. So if I have an application that sits across multiple cloud technologies or different components of my hybrid cloud infrastructure, I need to use a different tool to push changes to each component. So my application that resides in AWS, if I make a change, I need to make a change through whatever tools are available through AWS. And if it sits in VMware in my software defined data center, I need to make changes involved there as well. So there are different tools necessary, different things. And now I have to have this library and know which piece to use. And also, I need to try to create that consistency. So when I want to make a global change to an app that sits in multiple environments, I need to be able to translate my change into how the tool processes it for each different instance of how that application sits in my environment. You can see it's, again, getting very complicated. And to throw on that complexity, same function, different product. Let's talk about load balancing because we're here and we're going to be talking about load balancing here in a second. Load balancing is available in, for example, public clouds like AWS and Microsoft Azure. AWS has ELB, Elastic Load Balancing. Microsoft Azure has Azure Load Balancing as their quote unquote native or in house load balancing technology. They work completely different from each other. Their features are different, the configuration is different, and how you are leveraging it in terms of cost and everything else is different. And of course, you can't take the AWS ELB Elastic Load Balancing technology and bring it to Microsoft Azure. It's only available in AWS. You can't bring it to the VMware software defined data center, to your private data center environment. These technologies are specific to those vendors, even though they're supposed to do the same thing. How do we deal with that? How do we get same function, same product, same interface, single point of control across all these different environments? And of course, we will talk about that and address that. Different access to the same application. I want to make a change to my application in terms of how it works, in terms of maybe security rules or policies or load balancing decisions or something else. And I have to go through an interface through for AWS. I have to go through a separate interface for Microsoft Azure. I have to go through a separate interface for VMware, for OpenStack orchestration. So again, to make one change, at least one change, logical change, I had to make possibly 3, 4, 5 different physical changes because each environment requires different access and different tools. Operationally, this is becoming very cumbersome. And this goes back to the point that I said that, you know what, we are not saving money in the cloud because even though we're dissociating ourselves with some of the pieces like the infrastructure and the procurement and things like that, we're adding so many other pieces that at a minimum it's a wash in terms of your cost savings, and more likely your IT budgets are increasing. So how does load balancing come into play and fix it? So first, let's set the table straight. What is load balancing? Why are we doing load balancing? Number one is because servers aren't big enough. I can't build a server big enough to support all the people wanting to access this application. So I scale it out. So I have people accessing, and this is not a real website, mywebserver.com, and everything is happy. My people are my users, my clients, my customers are accessing my website. Everything's going fine. And then, you know what? Black Friday hits. A lot more people come to my website. And you know what? My server melts. It literally melts on the floor. Load balancing fixes this by distributing the traffic across multiple servers and systems and sites. And that's the second thing. Things break. So I have a lot of people going to my site and everything is happy. I'm king of the world. Everything is under my control. We are going full steam ahead. Nothing is wrong. And of course, you know what happens next? Something breaks. Data center fire, like I mentioned. Fiber cable gets cut. Somebody hits the emergency power off switch in the data center. Multiple reasons. Things break. It just happens. It's a fact of life. And when things break, when the Titanic starts sinking, what is your backup plan? Is it in place? Do you have something for your users to go to still access that application? That's where things like disaster recovery plans come into place, site redundancy. And this is also one of the reasons why we want hybrid cloud, because now we have multiple places that an application can sit in. So load balancing benefits, the key three things I like to talk about in terms of why do we do load balancing. This comes important when we talk about cloud, and you'll see the synergies here. Number one, scalability. We want to scale our resources as necessary quickly and easily to meet the demand for that application. Application demand changes over time, and we want to scale appropriately. Businesses grow, applications scale up, applications scale down, get deprecated, etc. We want that scalability so that we can ensure the application is there. And when I say there, I mean the application is available. We need a system so that when there is something like a server failure or a maintenance window for upgrades or patches, or when something happens, we have the ability to have the availability because the load balancers are doing the health checking and monitoring of the application to ensure that the traffic is only going to locations and instances of the application that can service the customer's needs. And third, we want agility, the ability to change things quickly and easily. So when we need that quick on demand for that Friday surge of holiday traffic, we can quickly make that change. When we want to add a new application quickly and easily, we can do that because load balancing gives us the flexibility to be able to make changes to the application and add applications and move applications without making major infrastructure changes across the board. So load balancing gives us that scalability, availability, and agility. And if you think about it, this is also what we want from this cloud and this hybrid cloud. So load balancing at 100,000 feet, it removes that single point of failure. It provides that disaster recovery technology capability. And because it's a reverse proxy, is acting as the public face of that application. So we can manipulate some things about access to the application and how the application behaves by doing it through the load balancer as the proxy. And this becomes a huge benefit. This becomes a huge benefit, especially because we can start taking the responsibility away from making individual changes to the individual applications and the individual environments and make the changes at the load balancer level where we can start creating some consistency. Does cloud need load balancing? I think, at least from my mind, the obvious answer is absolutely. But a lot of people think, again, I put something in the cloud and it's there, it's ubiquitous, it's always going to be there. And somehow the cloud just magically makes things work and available. As IT professionals, hopefully we learn that's not true. This elasticity, this flexibility that we want, like on demand, or some people call auto scaling. It has to be configured. It's not automatic. It just doesn't happen. I have to have some tools to be able to make changes to increase the application resources. The application availability, like I said, public cloud has failures. Hybrid cloud has failures. Private data center has failures. We need some sort of disaster recovery to ensure that when one location, let's say I have an application, you can see in the diagram, I have AWS, I have Microsoft Azure, I might have my private data center. Let's say the middle represents my private data center. And if one of those components fails, we need some technology to ensure that all the users that would have went to that one component that fails get migrated over to other components that are still available. So disaster recovery, this global server load balancing technology that we have within load balancing technologies can help provide that. Native public cloud load balancing, I mentioned that. It is unique to each public cloud. And if you're using a hybrid cloud technology model, it makes sense to start using technologies that are consistent across that hybrid cloud technology. So you might want to consider things like bring your own load balancer. Or for other technologies, you might say, bring my own firewall, bring my own IDS, bring my own WAF. But I might want to consider bringing my own third party technology that can be consistent across all the different environments if it fits in those environments. So when we load balance across this multi cloud, this is exactly what we want to do. We want to take this multi cloud, you can see in my diagram. I have my private data center, my public cloud, AWS, Microsoft Azure, and they're within the private data center. I could have my software defined data center with my VMware or OpenStack or other technology. And I want this consistent application access. And when I say application access, now I'm talking about the face of the application, the load balancer. I want it to be consistent across all my different environments. I would like it to be the same technology. I would like it to look and feel the same, to be configured the same, to even have a single management system that can look at the technology across all the different environments. So that now I can put my load balancing, such as Kemp load balancing, across all my environments in each environment. And from an operations perspective, the load balancing technology looks and feels the same. It's configured the same. There's no difference. There's a single management for it. It's the same technology. There's nothing being changed in terms of how it works, what features are available. And this is what we want to do when we look at this hybrid cloud environment, is really say, let's try to dissociate the individual base level of where the application sits, whether it's AWS public cloud, Azure public cloud, private data center, IBM cloud, it doesn't matter, and make it consistent so that it doesn't matter what that application sits in, as long as the technology that is managing and supporting that application, like the load balancing, can provide the front so that the users and the operators can manage this consistently. A big piece of this is licensing in the cloud. And when we talk about licensing in the cloud, let's look at how we typically acquire or consume technologies. So let's go back to this legacy or private data center model. And what I typically would have done as an IT professional is gone to a vendor and said, I want to buy X equipment. And this X equipment has a certain amount of capacity, and you are going to sell it to me, and I'm going to have it forever until it falls apart, until I kick it out the door, throw it away, or recycle it or do something. So, this is what we call the perpetual license. I purchase a perpetual license to use that technology, such as the load balancer. And now the technology could be hardware, it could also be software. So I'm buying a license for a piece of software that has a certain amount of capacity, such as 3 gigabits of traffic per second, a throughput, or X number of connections per second, or some other type of capacity plan. And I can use that forever. Usually, we also buy service contracts. We can discuss that later, which means the support, bug fixes, being able to call, being able to turn in hardware under warranty repair and get new hardware back, etc. The perpetual license is the traditional model of acquiring and consuming these technologies. And you pay for a certain amount, and you can see in the diagram, I pay for a certain amount, but I'm usually paying for a lot more than what I actually consume because I never want to hit that cap. Back in the service provider world, like the AT in the US here, we have AT&T and Verizon. We might have Orange, or we have some other BT, some other companies. They would provision their infrastructure and services to about what they would call about 40% capacity. In other words, when the utilization of their network hits 40%, they need to expand. So 60% of that network is unused for the most part, but it's there for bursts when there's big surges of traffic. It's also there in case of failure, disaster recovery. In case a data center fails, they need to have enough capacity so that they can still support the full load of traffic. That's often what we think of when we buy these perpetual licenses. But you know what? In the cloud, there are other models available now. And in general, we are extending this cloud technology and concept into the rest of the IT world to provide these other models. So we have this concept called metered licensing. Metered licensing is like exactly what it says. It's like having a meter, or like an electric meter that I have on my house. I now have an electric meter or a technology meter on the technology that I'm using. So, for example, if I apply this to load balancing, I can use whatever load balancing service, I can install whatever load balancing services I want anywhere that I want, but the meter is only going to charge me for what load balancing technology I actually consume. And that might be based on total megabytes, or peak megabits per second, or whatever way that they want to measure this through the meter. So let's use the analogy of the meter on my house. In my house, I have lots of electrical devices, and some of them use a lot of power. Some of them don't hardly use any power. Some are on 24/7. Some are only on when I flip a switch. I can plug in as much as I want into my house as long as it's not turned on and I don't pay for it. Only when I turn that switch on and when there's electricity flowing through that device, my lamp or my computer or my stove, then I get charged for the electricity that actually gets consumed. This is what meter licensing does. You only get billed what you pay for. Now, kind of the downside is you get a little less predictability because I'm getting charged monthly, just like my electric bill might skyrocket one month because we had a heat wave and my air conditioning system was running full steam. You might have some nuances with this metered licensing for the technology where you might have surges that you're not quite accounting for. But in general, it becomes very predictable as you scale, as you increase its use, and as you learn over time, you just start learning the predictability. So it becomes a very useful thing in terms of making sure that you only pay for what you use, which is really nice, especially when we talk about things like on demand and surges and things like that, where again, going to my e-commerce model, Black Friday, and I need to surge and have lots of traffic. So I need to more load balancers to support that traffic. I only pay for the traffic that actually gets sent out there. I'm not paying for the resources that aren't actually being used. And if you want kind of an in-between model of this cool concept of meter licensing, only pay for what you use, and this perpetual license where you just pay for it and you're done, we have a concept called pooled licensing. Pooled licensing means I buy a certain amount of capacity, but now I can slice that capacity up as I want. So I can buy 10 gigs of load balancing capacity total, 10 gigabits per second. And I can start carving that out, say, put 500 megabits per second here, 3 gigabits per second there, 50 megabits per second over there. However, I want to carve it out and push it out there as long as it fits within my total capacity limit that I have purchased. And I had the flexibility to pull it back into my pool and then recarve it into other pieces. So it's kind of like Play-Doh or modeling clay. For those that don't know what Play-Doh is, um, it's like modeling clay where I can pinch pieces off, put it out there, and when I'm done with it, I put it back into the big ball of clay, and then I can pinch a new piece out a different size if I want to and put it out somewhere else. I can pinch lots of little balls of clay out, etc. So pooled licensing is very nice to give us that hybrid of flexibility while still having very controlled cost, because I know that I'm paying for paying a specific amount for a certain capacity of pools. This big ball of clay, I know exactly how much that costs. So this pooled licensing, metered licensing, or perpetual licenses are all options when you're licensing in the cloud and in this hybrid IT infrastructure. And this is an important piece that we often don't touch on, because how we manage and procure and utilize these technologies in these hybrid environments is very important. So goals for load balancing in the multi-cloud, I think they're fairly straightforward. And here I'm going to highlight what I believe are the key points that we want and the benefits of load balancing in the multi cloud. Number one, we want to make it simple. We want to make the app deployment, the app management simple and easy. And this is true for the load balancing technology, of course, on top of that, because the applications are what you care about. The load balancing provides the access to the applications, the flexibility, the scalability, the agility, and you need some sort of simple technology that can do it right across all the different environments. Number two, you want flexible licensing. You want flexibility in terms of not just the application availability and everything, but also in the licensing, because you want to be able to control your costs, to minimize your costs, do a combination of the two, marry and figure out what makes sense so that you can now license the technology, a consistent technology across all the different hybrid IT environments, and keep that licensing model in place across the environments. Value. You still need to get value. You need to get the proper features and performance at a competitive price. That's always going to be true. And I think as you continue to extend your research into the different options, you'll find that for at least for load balancing technologies, using the third party across multiple environments, you get a lot of benefits, but you're also going to get much better features and performance at a better price than you would, for example, versus native load balancing built into public cloud infrastructures or private cloud infrastructures. So make sure you get the right functionality for the right price. And last, consistency for support. You want this common technology that looks and feels the same across all the different environments. You want to have the proper support infrastructure from the vendor that can support all the pieces consistently 24/7, 365 to make sure that this technology works as you expect it to, as you design it to, for all the cases that you want to be. And all this will help drive giving us that simplicity in terms of application support and operational support of these applications and the environments. Common mistakes that we see when we're talking about multi cloud, hybrid cloud, these hybrid IT environments is number one, business value versus dollar value. The cost upfront versus cost over time versus business return on the cost of the feature or function are often not weighed properly. Make sure you're doing the right thing for the right reason for the right price. It's not just about the technology. It's not about the technology being available. This point here is often why we see this concept of shadow IT. Shadow IT, where we have people like the developers, and I'm not trying to single any organization out or the network people or other folks in IT or business units in general, going off and making IT decisions in terms of purchasing, technologies, acquisition, implementation without a corporate overview because they decided that this was quicker and easier for whatever reason. Make sure that you can understand and approach this picture of the big overall IT infrastructure with a long term picture in mind. Number two, cloud is not someone else's computer. It's a great joke, it's a great meme, but it's not quite true. Cloud is pieces of infrastructure that you can take advantage of, but you still need to support and provide your own IT expertise to make it work right. You can't expect the cloud just to work out of the box. And along those lines, that agility, elasticity, that flexibility that we want out of the cloud, it's not automatic. We need to make sure that we have the scalability, the elasticity, on demand resourcing, the agility, ability to change things quickly and easily built into our infrastructure, this hybrid IT technology. And you're not going to get it inherently just because you use cloud technologies. You still need the other technologies that we used in the past, specifically load balancing technologies, to make those cloud benefits happen for you. And be careful about selecting and building piecemeal. You might be rolling out an application and the vendor or somebody decides that you should be using X platform, some platform that you're not using previously. Don't just do it just because in its own vacuum. Again, take a look at the big picture. Take a look at how things are going to work long term and try to make the appropriate decision. And make sure the decision folds into your overall strategy. You don't want to be building piecemeal, and the next thing you know, you have this smorgasbord of these 10 different technologies that are all, again, designed to do the same thing, but are doing it differently because you acquired them or implemented them independently. Make sure you try to build with consistency across the multiple environments. So, overall, conclusions that we want to take away is that number one, hybrid cloud. It's a model that is here to stay. It is not going away. We hear about all these concepts of cloud first, of SaaS, software as a service. Everything is going software as a service. We hear about cloud bursting and cloud migration, all these things that ultimately tell us that in the end, somewhere down the road, everything is going to be in a cloud and we're going to have everything sitting in the cloud and running there. It's just not true. We're going to be having a model that is mixed. We're still going to have this private data center concept. We're still going to have private virtualization or software defined data center or private cloud. And of course, public cloud will be a big piece of this as well. So we'll have AWS, Azure, Google Cloud, and who knows what other public cloud vendors will come up as well. And we'll also have these software as a service services like Salesforce, like Workday, and these other technology companies that provide these services through this cloud infrastructure. I again doing the air quotes that you can't see because their cloud infrastructure might just be their own private data center. They're just hosting the equipment on their own terms and providing this access to the service. They might not even be in a public cloud. They might be somewhere else. But hybrid cloud, in terms of the mix of these different IT architectures, is going to be a fact of life for a long time for every organization. And unifying the different disparate or different parts of these clouds is going to be critical. The hybrid cloud means that we need to deal with cost management, whether it's through licensing or operational efficiencies, simplified support. We need to make sure that this hybrid cloud technology is as unified and as simple as possible. So we need to leverage consistent technologies and concepts across this hybrid cloud, across these different environments. And that's where the load balancing comes in. Load balancing is a key component sitting in front of the application, managing the application access, and doing other great things with that application access for security, such as web application firewall, layer 7 switching, and content manipulation. That it provides the cornerstone of providing consistency across these multiple cloud environments if you pick a technology that can work across the different cloud environments. Load balancing can unify these different application deployment models. So the application, whether it's sitting in AWS or in a private data center running on VMware hypervisor, from a user perspective, from a network operations management perspective, it can look and feel the same. We want to maintain that consistency across the load balancing environment to help unify everything so that the look and feel is clean across the different environments. This is our goal, excuse me, with these hybrid cloud environments, is to really try to find a way to get the consistency to provide a single look and feel so that the hybrid cloud really looks as like one cloud to all of us. So, last bit I have to throw in here. Kemp, providing load balancing technology and network telemetry technologies. We believe we're a vendor position for your multi-cloud journey. We have the form factors for the different environments, whether it's virtual for your private data center, cloud, Azure, AWS, etc., and your hardware-based load balancers. They're available. They're consistent. It's the same software build, basically. The look and feel, the management is consistent. One management system, no matter where they sit or what form factor they are in, is available today. Download a free trial, kemp.ax/VLM virtual loadmaster-download, or of course contact us at Kemp at sales@kemp.ax, and we're more than happy to work with you for your load balancing technology needs for all your different environments. So I appreciate y'all taking the time to listen to this. Hopefully there was some value in this, and hopefully you'll find some value in talking to Kemp. Of course, if you're interested, follow us on the Bright Talk channel and our YouTube channel and Twitter. And we're more than happy to talk to you about anything in terms of technology and load balancing needs. I appreciate you taking the time to listen to this, and hopefully you'll have some good conversations and listen to some great things to the rest of the summit. Thank you very much. Have a great day.